Hello everyone. Today our topic is spread spectrum modulation. See, in this name itself, you could witness the spread spectrum modulation. What is spread spectrum modulation? See, the spread spectrum in the sense simply the spectrum means the bandwidth, and the spread is nothing but we are widening. So combinedly together, widening the bandwidth. We are widening the bandwidth by means of some technique. This is called spread spectrum modulation simply. So the spread spectrum modulation in here, the original signal, that's a message signal, is multiplied with some other signal that is obviously called as a pseudo random noise spreading code, so that the narrow band signal which is converted into wide band signal. So this is called a spread spectrum, where spectrum is widening, that is called spread spectrum. So here, according to the statement, the spread spectrum is a technique by which a signal generated with a particular bandwidth is deliberately spread in the frequency domain, resulting in a signal with a wider bandwidth. So there are many uses, many advantages are there of spread spectrum. There are reduced crosstalk and interference, better voice quality or data integrity, low susceptibility to multipath fading, much improved security with minimum complexity, allows for coexisting signals over a wide bandwidth. Within ISM, that is industrial, scientific, medical band, one can have greater signal power, that is greater distance can be achieved. Then hard to detect its presence. So by the security reasons, that's a very it is useful in security purpose. Hard to intercept and or spoof, harder to jam a spread spectrum signal. So these are all the several uses of the spread spectrum. So this is the general typical block diagram of spread spectrum modulation. Here we have input data, channel encoder, modulator, pseudo noise generator, channel demodulator, then channel decoder, then finally output. Here the spreading code or sequence is generated by pseudo random generator using a seed and is deterministic. Then modulator using the spreading code to modulate its input to match a wider bandwidth output for transmission. So from this, the pseudo noise generator generates the codes that will be a very high frequency, very higher chip rate. So the chip rate is nothing but a wide band. So this chip rate and the input signal is multiplied, so the spectrum will be widened. So the modulator using the spreading code to modulate its input to a much wider bandwidth output for transmission. So the demodulator using the same spreading code to the demodulate the spread spectrum signal. So here one more thing we need to see. So here, before the modulation and demodulation takes place in the spread spectrum, both the transmitter and the receiver section pseudo noise generator should be synchronized, so that the receiver, the same kind of a signal what is transmitted from the transmitted signal can be easily detected and demodulated. So others cannot interfere with this communication. So here, spread spectrum technique, there are two types. One is direct sequence spread spectrum, another one frequency hopping technique. So first let us see direct sequence spread spectrum. It is simply called as DSSS. Here the direct sequence spread spectrum is a spread spectrum technique whereby the original data signal, there is a input signal, is multiplied with pseudo noise generator. That pseudo noise generator will spreading the some codes. The spreading codes has a higher chip rate. Chip rate is a bit rate of the code, resulting in a wideband continuous scrambled signal. So finally will be once the original signal is multiplied with the pseudo noise generator signal, the output will be a wideband signal. So that is direct sequence spread spectrum. Here the sequence of the signals which is given to the modulator. So that's why it is called as a direct sequence spread spectrum. From this you can see in this diagram the message bandwidth. Here you see the message bandwidth is some narrow here in this diagram, and after converting from the spread spectrum modulation technique, the signal bandwidth is widening, right? Because of this concept only we are calling it as a spread spectrum technique. So in the direct spectrum technique also the same thing is employed. So this is the DSS transmitter. Here the message signal is given to the modulator, that will be multiplied with the PN code generator, that is a pseudo noise code generator that has a chip clock P of T, and so that output signal is P of T and the message signal is M of T. Both will be combined and that will be given to the baseband BPF, band pass filter, and again will be given to the modulator. The modulator already having a oscillator signal, that is FC. So FC and the baseband signal is multiplied, and the final signal is a spread spectrum signal. That is since it is it uses the direct sequence of signal, that is called as a direct sequence spread spectrum signal is getting at the output side, that is represented as SS of T. Here the output is mathematically represented as SS of T equal to root of 2 ES by TS M of T into P of T cos omega CT. So this is nothing but of chip generator, the modulator circuit. The modulator circuit will have a chip generator and the original signal, and finally we'll be having a spread signal. This already we discussed. Once the pseudo noise generator is multiplied with the original signal, the final output will be a spread spectrum signal. So that is represented here. So this is the example for DSSS. So here the transmitter data input A. So there is a series of bits is given, and locally generated PN bit stream that has a higher bandwidth. That signal will be multiplied with the data input. So the transmitted signal C is given below. Again at a receiver signal, received signal C will be received at the receiver by means of decoding the transmitted signal. The same before that, with the both the noise generator, pseudo noise generator should be synchronized. And the advantage and disadvantage of DSSS is it has best discrimination against multipath signals. It avoids intentional interference such as jamming effectively. Then performance of DSSS system is presence of noise is better than FHSS system. Then drawbacks, the system becomes slow due to large acquisition time. It requires wideband channel with small phase distortion. Then the pseudo noise generator should generate sequence at high rates. Then the application is, it is used in a low probability applications, and it is used in a military and many commercial applications, and it also used in a CDMA, that is code division multiple access. So the next technique, frequency hopping spread spectrum. So the previously discussed is direct sequence spread spectrum. So the major difference between these two is nothing but of, in a direct sequence spread spectrum, the series of bits is modulated, and that will become as a spread spectrum. But here frequency hopping spread spectrum, the signals rapidly change, the carrier signal rapidly change. This is called a hopping, right? So this kind of a method is applied over here. So this is the first difference, the major difference between these two, frequency hopping and direct sequence. So in frequency hopping spread spectrum, the signal is broadcast over multiple frequencies in a pseudo noise pattern. Both transmitter and receiver must know the pseudo noise pattern to successful receiver communication. This already we told in direct sequence spectrum itself. So before communication, both the pseudo noise generators should be synchronized so that the detection will be easier, and also the others, external devices, external things cannot be able to interfere and able to detect the signals. So the basic operation of FHSS is, here the typically 2 power k carrier frequency forming 2 power k channels, The channel spacing corresponds with bandwidth of input, each channel used for fixed interval. So this is the example of FHSS. Here the x-axis in the first channel assignment diagram, x-axis is represented by frequency and y-axis is represented as energy. So F1, F2, F3 up to F8, there are the slots is channel is assigned. In the channel use in the second diagram B, so you could see x-axis is time and y-axis is frequency. So in each and every time period, the signal, the carrier signal is rapidly changing, that is hopping. So this is clearly represented here, and this is also the one of the example of FHSS. Here the bit stream, bit patterns 101, 111, 001, 000, likewise that will be hopped in the frequency hopping techniques as we discussed in the previous slides. So this is the frequency table. So here first selection is 101. So 101 k bit is 101. The corresponding frequency is 700 kilohertz. This is the first hop frequency. Likewise, the other data bit streams will be transmitted, will be hopped. So this is also the example where you could see the frequency hopping clearly. And this is the FHSS transmitter. So here the binary data is given to the modulator, where the modulator which uses either FSK or PSK or PPSK, and the output of the modulator is SD of T, which is given to the FH spreader. That FH spreader, another input is from pseudo noise bit source and given to the channel table, and that will be frequency synthesizer, and the output of the frequency synthesizer is C of T. So both C of T and SDT of T will be combined, and that will be given to the band pass filter. And finally, this makes this pseudo noise bit generator will makes the signal into a wider bandwidth. So finally, the output of the FHSS transmitter is S of T, that is a spread spectrum signal. So the spread spectrum gives signal which is transmitted at the transmitter end will be given to the detector, that is a receiver. So here also the same concepts. S of T will be given to the frequency hopping disparator, and another one signal for frequency hopping disparator is pseudo noise generator as in transmitter side. So before the communication, we already know the both the generators should be synchronized. So the output of the FH disparator C of T and S of T is multiplied, and that will be given to the band pass filter. So that is actually SDT of T. Before giving to the band pass filter, the signal is SDT of T and will be given to the band pass filter. And again, we will be having a demodulator of either any one method can be applied, that is FSK or PSK. Because since we used FSK or PSK in transmitter side, so here then it is, since it is a receiver, the demodulator either FSK or PSK or should be used. So finally, the binary output data will be obtained from the FHSS receiver. Then the application of frequency hopping spread spectrum, it is used in many space systems and avionics system, and also for multiple access communication. So multiple access communication in the sense there is a TDMA, time division multiplexing, and frequency division multiplexing, and code division multiplexing access. So these are all the multiple access communication. There the FHSS it is used. Then another one advantage application is protection against jamming and interference. So if you need your communication should be more secure, then you can go for frequency hopping spread spectrum, because since it has a protection against jamming and interference. Thank you.